Hello, we are doing problem number 1 from your Geometry Part 1 textbook. This is found on page 107 of the textbook. We're talking about what's called the law of detachment. In this lesson, there's actually two that we'll deal with. Problem number 1 is called the law of detachment. And the best way to show it is to go through these couple of examples. A says, given if a student gets an A on a final, then the student will pass the course. Then the second statement says, Felicia got an A on her history final exam. Now, these are talking about if-then statements. So if the hypothesis is a student gets an A on her final exam, then the conclusion is the student will pass the course. Well, the second statement has to do with A. Felicia got an A on her exam. That's why they're both in red there. So the second statement matches the hypothesis of the given conditional. By the law of detachments, then you can make a conclusion that Felicia will pass her course, which comes from the conclusion of the original statement. We used to say it as if A then B. And so if A is true, then B will also be true. That's kind of the thinking behind what we call the law of detachment. So let's look at another one. B. If a ray divides an angle into two congruent angles, then the ray is an angle bisector. So again, the hypothesis and the second statement is that ray RS, divides angle ARB so that ARS is congruent to SRB. So again, the hypothesis of the original statement is that a ray divides an angle into two congruent angles. B says if the conclusion is that the ray is an angle bisector. So the second statement comes along and supports the original hypothesis that RS does divide that into two equal segments. Therefore, we can conclude by the law of detachment that the conclusion would be that RS is an angle bisector, because that's what the original conclusion would conclude. That idea of if A matches if the second statement matches the original hypothesis, then we can get the conclusion from that. Okay. C. If two angles are adjacent, they share a common vertex. Angle 1 and angle 2 share a common vertex. Okay. Now, I want you to see how they've color-coded this, because the second statement this time is matching the conclusion of the original statement. If two angles are adjacent, that's the hypothesis, then the blue part, then they share a common vertex. That's your conclusion. Statement 2 says 1 and 2 share a common vertex, so it's talking about B, or the conclusion, and not A, the hypothesis. And so because of that, it doesn't tell you that the angles are adjacent. The second statement does not match the hypothesis of the given condition. So we can't use the law of detachment. I wouldn't say that it wouldn't be true, but we can't use this process or this idea that we're calling the law of detachment. Angle 1 and 2 could be vertical angles, since vertical angles also share a common vertex. But you can't make a real conclusion because the second statement was about the conclusion and not about the hypothesis. So in contrast, number C is trying to show you what the law of detachment doesn't look like. Okay? Look at the got it. What can we conclude from the given information? If there is lightning, that's your hypothesis, then it is not safe to be out in the open. That's your conclusion. Maria sees lightning from the soccer field. Since, again, her statement is following the hypothesis, then we can say that it is not safe for Marla to be out in the open. Okay. B, if a figure is a square, then its sides have equal lengths. Okay? But the second statement, figure A, B, C, D, has sides of equal lengths. Well, that's talking about the conclusion, so we can't make a conclusion out of that using the law of detachment. So B, we can't. A, we can, because the second statement had to deal with the original hypothesis. Okay? I hope this helped a little.